Okay, today we're working on 6.5 day 2, which is solving problems using quadratic equations. What we want to do first is to activate our prior knowledge here is to look at this first equation, finding the roots of this parabola given by y equal x squared minus 8x plus 7. What we know here is that we want to look at the 7 first. We're looking for two numbers that multiply to 7 and add up to negative 8. And the only two numbers that can do that are a 7 and a 1. So in this case, we have negative 7 and a negative 1 because two negatives multiply to positive 7 and they also add up to negative. So very simply, we have y equal x minus 7 and x times x minus 1. And we know that if we're finding the roots, of course, the y value has to equal 0. So we could say 0 equal x minus 7 times x minus 1. And if that's the case, then our roots are, either x minus 7 equals 0 or x minus 1 equals 0. If x minus 7 equals 0, then we solve properly here at x equals 7, and we solve here x equal 1. So those are our two roots. Here we're going to complete the square to solve this. I'll use this different feature so it'll be a little bit easier. So I'll rewrite the equation. Y equal 3x squared plus 30x plus 79. That's what it asks us to do. Complete the square to find the vertex. Remember, the first step in our algorithm is to put brackets around the first two terms and ignore the third. So we'll say y equal, and now we want to take out the greatest common factor, the numerical coefficient at least, and that would be 3. So 3 times x squared plus 10x plus 79. And remember, the key number here is 10. We want to halve the number 10, H-A-L-V-E, half it, cut it in half, and we are going to then square that number. Half of 10 is 5, squared is positive 25. We're going to add that, and we're going to subtract it. The reason why we add and subtract it is because technically it doesn't change the question. We've maintained the integrity of the equation. Now we have y equal 3 bracket x squared plus 10x plus 25, and what we want to do here is keep in mind we want to get rid of this negative 25. We want to boot them out here, but before we do so, we have to remember that we have everything in the brackets being multiplied by 3. So first, we multiply 3 times negative 25, and then we can boot it out. So in that case, we're left with, we have our positive 79, and then subtract 75. If we simplify this further, we get 3, or we're factoring this now, we get x plus 5 squared, and 79 minus 75, of course, is plus 4. So we could say that the vertex equals negative 5, 4. That is the coordinate of the vertex. All right, let's move down here further. For this question here, I went ahead and drew a diagram to help us understand what the question's asking us. So here's where we're using a problem, a garden problem, for example. So the area of a 40 meter by 30 meter garden will be doubled by increasing the length and the width by the same amount. So you'll notice here that I wrote in blue the current existing garden here. This is the blue area. So this whole blue area is the existing garden. Okay. And what we have in the red area is what's going to be added. So I extended the 40 meters by this amount x. I've also extended the 30 meters by this amount x. So the total area added is this whole area here. That's the expansion. So this area that's being added will in effect double the area of the garden. So let's work with what we know first. What is the current area? Well, the current area of the garden is the blue section, which is 30 times 40. And that's going to equal 1,200 square meters. Not too bad. The area of the new garden is double the existing garden. So in that case, it equals 1,200 times 2, which you know equals 2,400 square meters. So we know that the entire area of the garden, once it's expanded, let's just do this in a different color. The entire area of this whole garden, the entire thing, will equal, let's do it like that. This entire garden will then equal 2,400 square meters. Right, now so if we're solving this, we want to look at the new area. So the new area we know is 2400, and area is equal length times width. Okay, so the new area is 2400. I think I'm going to use this strategy here because it's a little bit neater. So the area is 2400 square meters equals length. Well, the existing length was 30 times 40, but the new length is 30 plus this addition x, and the new length, so the length is 30 and the width is 40 plus that new added portion. So if we're going to solve this, we have to basically find the roots. So we're going to create a quadratic equation in standard form and then use the quadratic formula if it's not factorable. So let's continue here. We have 2400 equal, and now we have 30 times 40, which is 1200, and then 30 times x, which is 30x, and then x times 40, which is plus 40x, and of course x times x, which is plus x squared. Continue our simplification. We have 1200, and then 30x plus 40x, of course, is 70x, and then we have plus x squared. We want to get, for the roots, we know that the y value has to be equal to 0. So what we're going to do now is we're going to subtract 2400 from both sides. So I'll say we'll say 0 equal 1200 plus 70x plus x squared minus 2400. And of course, our like terms are 1200 and minus 2400. And we will continue to simplify. 1200 take away 2400 is equal to negative 1200 plus 70x plus x squared. Now that's not the order you're used to seeing this in, so let's switch around the order. Let's put the x squared first, it's positive. Let's put the positive 70x second, and it's also positive. And the negative 1200 will go last, and there it is. This is not factorable, and the numbers are a little bit large to start dealing with, so let's use the quadratic formula. We know a equal 1, b equal 70, and we know c equal negative 1200. Let's plug that in our quadratic formula, which is x equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And our numbers again are a1, b70, c negative 1200. So we know x is going to equal negative 70 plus or minus. You might want to pause the video and see if you could just do this on your own. B squared is 70 squared minus 4 times a times c, which is negative 1200, all over 2 times 1. I like to look at the part known as the discriminant, which is the part under the square root symbol. I like to do that separately. So 70 squared minus 4 times 1 times negative 1200, and I'll use this. Sorry, it's 70 squared. So 70 squared minus 4 times 1 times negative 1200 should equal 9,700, and it does. So I know I have negative 70 plus or minus the square root of 9,700 all over 2, because 2 times 1 is 2. So really our roots are negative 70 plus the square root of 9,700 over 2, or we have negative 70 minus the square root of 9,700 all over 2. One of those two. So what does that equal? Let's use our handy dandy calculator here. Negative 70 plus the square root of 9,700 all over 2. And we get 14.244. So that's going to equal 14.244, or let's plug this back in here, and we're going to change our addition to subtraction. And we get negative 84.244. Negative 84.244. Now, if we're talking about an addition to a garden, clearly the negative 84.244 is not valid. So the answer we're looking for here is 14.244. That is the correct answer. But the question asks us to find the new dimensions. We can't stop there. So we need to answer the question. New new dimensions. We originally had 30, but it was 30 plus x. So remember the dimensions were 30 plus x times 40 plus x, and that would get us 2400. So let's plug in what we know. We have 30 plus 14.244 times 40 plus 14.244. And so our numbers are going to be 44.244 for the length, and the width will be 54.244. And these are our two new dimensions. So that would be your answer. But let's just double check our answer. So we have 44 and 54.244. So 44.244 times 54.244, and let's see what that multiplies to. And it comes out to 2,399.971, which is rounded to 2,400, of course. All right, so that's our lesson for today. Hope that helps. Use diagrams to help you when need be, and we'll see you in class.